Renewable energy in Malaysia focus on solar, as we know. Solar energy is basically it's not all day long. The optimum time for solar generation is around 10 o'clock to 2 p.m. So what we need is energy storage to store the energy generated by the solar. That's where the energy storage comes in lah. It store the energy generated by renewables and to be used later. Alright. And basically energy storage support in many ways. If you go to the larger scale of things, if you have a big solar farm, basically it can support the national grid, right? It can supply energy to the grid, thus it will gives more stability and less strain to the national grid lah. First of all, the energy storage currently used is not cheap. Basically it's not cheap. The most reliable nowadays is lithium-ion battery. And lithium-ion battery is not cheap. That's the one, the first challenge. The second one, basically is the integration into the grid or the system, the overall system of the electricity lah. The integration basically is not straightforward lah. You need to ensure compatibility. You need to optimize the control system. And also you also have to address the problem of grid stability lah. If you want to integrate the energy storage system into the grid. Okay. Then the third one is technological advancement lah. Basically we need more research and development effort to enhance energy storage technology. Right now, if we need to have a better batteries, cheaper batteries, so that the adoption can be wider lah. So another one is regulatory and policy framework. Basically, we need to have a clear and supportive policies and regulation from the government, basically to incentivize the deployment of energy storage in the the everyday use. Basically we need a better performance battery in every aspect. You need to have a cheaper battery, higher storage capability, and long life. That's that, and safe. That's the basically we can say mandatory requirement for energy storage system. Okay. Basically we've been doing this for a long time lah. We started out in 2018. Okay. No. 1988. 98. Sorry. Okay. Back then we focus on research and development, like synthesis of new battery materials, which we can say rather fundamental research. However, in 2016-2015, we started to embark on finding the application for the batteries. Okay. So during that time we have developed our battery to be used in quite some application like solar street light, EV, cars and motorbike, and stationary energy storage. Okay, so basically the renaming to ICI Advanced Energy Storage indicates a greater emphasis on the battery in EV and battery energy storage system lah, in industrial application. Now, basically in term of battery, we focus on application of the battery in industry. Basically, we have a complete laboratory set up for doing R&D in battery, including we can do synthesis, we can do physical and chemical and electrochemical analysis, creation of the new material for batteries. And also we have a pilot plant for producing what we say a workable cell that can be used in real application. For quantities waste to industries, basically such as to determine the right lithium-ion battery solution for their application, be it stationary or mobile. And we also provide initial concept consultation from lithium battery design until final product realization. Okay, to ensure the right battery pack that meets the specification for the desired application. So we can do also battery testing to characterize and to see the performance of the battery. Okay.
What kinds of energy storage are we looking at this year and why?
Okay, current trend basically every day we see EV. We see and hear EV, right? So that is the obvious thing lah, kan. However, as the country is moving towards zero carbon policy, energy generation from renewables will be one of the important things in the future. In the heart of renewable energy is basically energy storage, whereby the energy is stored and to be used later. As you know, renewable is basically, if it stand alone, is not really reliable. As you can look at solar energy application, the optimum time is from 10 to 2 o'clock, let's say, and that is when the day is on a good day lah. We were involved in research and development of new material for battery. The goal is to produce a battery with high capacity, high power, and at the same time cost affordability. Okay, so far we have developed a battery what we call MyLipos, which is based on lithium iron phosphate chemistry. And this battery has been installed in our EV prototype, in e-bike prototype, solar street light, and stationary application. As for now, we are continuing with our R&D in search for a better battery, basically, and we try to find a new application for the battery also. Ion battery has a potential to contribute to the sustainable energy, what we say, movement, based on several premises. One is abundance of sodium. Sodium is basically is more abundant and widely available compared to lithium. Sodium, if you look at the ocean, it's basically abundance in the ocean in the form of sodium chloride. So this accessibility can help overcome the supply constraint of lithium. Okay, that's the first one. And then cost reduction, uh, because you know the abundance of sodium, it has a lower cost. So basically it can reduce the dependence on lithium, and consequently we will have you know a less mining. As you know, lithium we mine to get lithium. So this in turn will you know reduce environmental concern lah. Ion battery is still in the early stage lah. So apart from sodium ion battery produced by CATL China, we haven't seen the battery, sodium ion battery has been commercialized yet lah. So
is the one that you just mentioned in China, has it been commercialized as well? Or is still
the China, they plan to commercialize, but in reality they haven't commercialized it to the market yet lah.
what kind of application are we
Basically,
sodium?
the application is quite the same with lithium ion lah. But the potential is more towards stationary energy,
Or stationary
energy storage, because there's a thing that we call the energy density, which is the energy base, the energy stored compared to the weight. Okay, lithium has a better or higher energy density, so that in case of if you take EV for instance, for the same amount of power or battery power, you need to have more sodium battery as compared to lithium battery to deliver the same power. Okay, so in term of EV, basically the lithium ion is better. You definitely need a lighter vehicle lah, basically. But in a stationary application, because of its cost, affordability, I think sodium ion will be a better choice in the future. You know, the abundance of sodium in the in the world, basically, I think the ease of you know capturing the sodium, I think it should be cheaper.
cheaper? Okay.
Goal is basically to push the integration of energy storage in renewable energy generation through what we call battery energy storage system lah, or in short BESS. That can be used as peak demand management tools in factory, whereby energy storage, if is used to manage peak demand, so in turn it will reduce the utility bill from maybe around 10 to 30%. Okay, and so we are here basically to support the industries in their endeavor or their business by providing consultancy, performance and safety testing of their products, and we will continue with our research on the development of new materials, for batteries in order to achieve better performance battery compared to the current one. So we will also initiate the development of solid state hydrogen storage technology here in SIRIM, and our midterm initiative also we are focusing on the development of sodium ion battery, proof of concept and pilot production of sodium ion battery cell, and to demonstrate the capability of solid state hydrogen storage system in mobile and stationary application. Long term, apart from continuing with our R&D, we foresee the concept of self-generating, self-consuming, where you use the energy you generate. So you don't, basically you are independent from the grid. So, but to achieve this vision, we need to have a better, if solar, we need to have a better efficient solar generating PV lah, and we need also to have a better energy storage system that is affordable. Okay.